an independent voltage source over there and a bunch of resistors. So what we have to do is to find the voltage V. So what we have to do first is to identify our nodes. So we're going to go here and identify our nodes. So we're going to have a node there and a node there. And then we can call this a reference node. So we have to label our nodes. So we're going to call this one V1 and we're going to call this one V2. So what we have to do now is to use node voltage analysis. So we have an incoming current over here. So we have an incoming current, and that current, we have other current going out like that. And remember, we take outwards as positive and inwards as negative. So what we're going to do right here, we're going to say the incoming current 4.5 amperes. So we're going to have negative 4.5 plus this current that goes out. So we're going to have plus, because it's going out, we say it's positive. So we're going to say V1 divided by that resistor over there. So the current that goes through here is V1 divided by that resistor. And then the other current that's going out, so we have plus V1 minus V2, V1 minus V2 divided by the sum of those resistors in between. So we have 6 plus 2. And then we set all of that equal to 0. So from here, what we have to do is to take this 4.5 to the other side and then solve these and simplify this equation. And you're going to have something like this. So we're going to call this equation 1. And now we head over to the node 2. So we have node 2 over there. So we're going to do the same thing. So we're going to say there's a current going out, and current going out. So we're going to start with this current over here. So what we're going to do now is we're going to go to here and say V2 minus V1 divided by the sum of the resistors in between, which is 6 plus 2. And then we have another current that's going out, which is V2 over 12 ohm. So we're going to have V2 over 12 ohm. And we have another current that's also going out, which is V2 minus 30 volts divided by the 4 ohm resistor. So we're going to have V2 minus 30 divided that by 4 ohm resistor. And all of that is equal to 0. So now what we have to do is to simplify this equation. And you should end up with something like this. And now we're going to call this equation 2. So now that we have two equations, two unknowns, we can solve this simultaneously, or we can simply just put this into our calculator and solve for V1 and V2. And now we get V1 is equal to 6 volts and V2 is equal to 18 volts. So we can go over to the sketch. So now we know that this is 6 volts and that is 18 volts. So what we need to do is to find V. So we have to find the current in between V1 and V2 before we can get to V. So we have to find that current. So that current is, so we're going to say I is equal to V1 minus V2 divided by the sum of the resistors, which is 6 plus 8. So we already have V1, which is 6. So we're going to have 6 minus 18 divided that by 8. So you should get something like negative 1.5 amperes. So that will be your current. So to get the voltage V, we're going to have to multiply that current with the resistor of 2 ohms. So we're going to have to say the current is equal, the voltage V is equal to the current I multiplied by the 2 ohm resistor plus the 18 volt, so which is V2. So I'm gonna say V is equal to 2 multiply that by I plus V2. So we're gonna say 2 multiply that by negative 1.5 plus 18, and you should get 15 volts as your final answer. So heading over to the next example, so we're gonna do the same thing as before. So we're gonna identify our nodes. So we're gonna have a node there and a node there, and then we can call this our reference node. So we have to label our nodes. So I'm gonna call this one V1 and I'm gonna call this one V2. So we're gonna do node voltage analysis at V1. So we can assume that all the currents are going out. So we can just say this current is going out, and then we have that is a current source. So we're gonna just say this is coming in, and then we have out and out. So we're gonna go to that node and do our node voltage analysis. So we're gonna say that current that's going out, we're gonna have V1 minus 50 divided by the 6 ohm resistor, and then plus V1 divided by 8, which is this current over here, and then plus V1 minus V2 divided by the 2 ohm resistor, which is this current right here. And then we have the incoming current, so we're going to have minus, and that current is equal to 3I1, and all of that is equal to 0. So we have V1 and V2 as our variables, but we also have I1 as one of the variables that we have. So we have to get rid of it. So we're gonna go here and just say right, but I1 is equal to 50 minus V1 divided that by the 6 ohm resistor. So what we have to do now is to substitute this I1 into this equation and simplify the equation. You should get something like this, and then from there you can call this equation 1. So now we're going to go over to node 2, and then we're going to say there's a current going outside, and there's a current going out, and this one is going in. So we're going to do our node voltage analysis at that node. So we're going to go here and say node voltage at V2. So we're going to start with this current that's going out. So we're going to say V2 minus V1 divided by that resistor. So we're going to have V2 minus V1 divided by the 2 ohm resistor plus the current that's going out, V2 over the 4 ohm resistor. So we're going to have V2 divided by that by 4, and then we have the incoming current, which is minus 5, and then we have the outgoing current, so we have plus 3I1, and all of that is equal to 0. So again, we have to remember that I1 is equal to 50 volts minus V1 divided that by the 6 ohm resistor. So we're going to substitute that into the equation and then simplify our equation. You should get something like this, and then you're going to call this equation 2. So now you can solve this equation simultaneously, or simply just put it into your calculator and get the voltage V1 and V2 just to save time. And now you should get V1 is equal to 32 volts and V2 is equal to 16 volts. So let's see, what were we calculating? So forgot to mention what were we calculating here. So we are trying to find I1, the current I1. So say find I1. So we need to find I1. So now that we have V1, we can find I1 using this equation right here. So let's go ahead and do that. So we're going to have I1 is equal to 50 minus V1. And what was our V1? 32 volts. So we're going to say 50 minus 32 divided that by 6. And then you should get something like this, 3 amperes. And that would be your final answer. Sorry for not writing the instruction first. So here's another example. So this one is a little bit complex, but we still apply the same method as we did previously. So what we have here is we have an independent current source, a dependent voltage source, and an independent voltage source right there. So note this, whenever there's an independent voltage source here, so we're going to have something called a super node. So usually we have a node like this, that's a node, and a node, and a node. But since we have an independent current source right here, so now we have what we call a super node. So basically this whole thing right here, it's a node. This whole thing right here is a node. It's a single node. So we're going to start by labeling the nodes that we have. So we're going to have this one, so we can call this V1, and then we can call this node right here V2, and then we have all of this as a super node. So we're gonna do node voltage at V1. We're gonna go to V1 and then start doing our node voltage analysis. So we're gonna say node voltage at V1. So when we look at V1, we have an incoming current. So we have an incoming current and outgoing current, and we can say that one also it's outgoing. So we're gonna say the incoming current, so we're gonna have minus 6 amperes, and then the outgoing current plus, that will be V1 divided by 7.5, and then we have another outgoing current, so we're going to have plus V1 minus V divided by 2.5. So we're going to have V1 minus V divided by 2.5, and all of that is equal to 0. So from here we're going to simplify our equation. Now you should get something like this, and then you can label that equation 1. So from there we have to move on to the next node. So now we have to focus on the super node. So on the super node, like this node right here is basically a simple single node which has a current going out here, current going out, current going out, and another current going out. So simply something like this, and 2 currents going, something like that. So let's start with this current. So we're gonna have a V minus V1 divided by 2.5. So we're gonna say node voltage at V2. So we're going to have V minus V1 divided that by 2.5, and it's going out, so that is positive. And then we have another one that's going out, which is V divided by 5. V divided by 5 ohms, plus another one that's going out, which is V2 divided by 2.5. So we have V2 divided by 2.5, and we have another one that's going out, so we have V2 minus 9 divided by 1 ohm. So we have plus V2 minus 9 divided by 1, and all of that is equal to 0. So what we have to do from here is to simplify the equation. So you should get something like this. So you can call this now equation 2. So when you look at equation 1 and equation 2, we have 2 unknowns on equation 1 and we have 3 unknowns on equation 2. So we don't have V2 over there. So what we can do here is to do this, is to move this V1 to that side, and then what we can do here is that we can say plus V2, multiply that by 0. So now we have 3 unknowns on equation 1, and then we have 3 unknowns on equation 2. So let's try to solve that. But this is not going to work since we have 3 unknowns, 2 equations. So we need 3 unknowns, 3 equations. So we do not have the third equation. So this is not going to work. So what can we do? So we're going to go back to our diagram here. So we're going to see that we have Ix and Ix over there. So we're going to have a constraint of this dependent source. So we're going to say that Ix is equal to V1 divided by 7.5. And then we're going to have another constraint which says V2 is equal to this voltage right here plus this voltage right there. So this is voltage. It's written Ix, that is because the value of this voltage is the same as the value of the current Ix. So we're going to have V plus Ix. So this is what we have right here. So what I'm going to do from here is that I'm going to convert these equations into this form. So I'm going to do this. I'm going to say 7.5, multiply that by Ix, and then I'm going to take this V1 on the other side. So I'm going to say minus V1, and all of that is equal to 0. Or I can simply do this. I can say minus V1 into 1 over 7.5 plus Ix is equal to 0. And same goes for this one right here. I can take everything to the other side, and then I say that is minus, and then I can say all of this is equal to 0. So basically now what I have is equation 3 and equation 4. So now we're going to put all of these equations into standard form. So I'm going to put them easier. So I'm going to say, so now from these 4 equations, 1, 2, 3, 4, I have something like this now. So now I just put them in standard form. So I have V1, 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 V2, 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 V2. So wherever I do not have V2, for example, in this equation 3, I do not have V2, and equation 1, I don't have V2. So I multiply that V2 by 0. I multiply by 0, and then here, whatever that I don't have in other equations, I just multiply by 0. So here I do not have ix, so it's 0, and also here on equation 2 it's 0, and I have it on the other two equations. So now that I have 4 unknowns, 4 equations, now I can solve this simultaneously. So to solve this 4 equations simultaneously, since my calculator does not have that function, so what I did basically is that I just look at equation 3 and 4. So I have positive ix over there, and then I have negative ix over there, and on the other equations I do not have ix. So I can eliminate that ix, so by simply just adding up these two equations. So by adding them up, I cancel out ix, and then the result, I take it as my new equation 3. So now that I have 3 unknowns, 3 equations, I can put that into my calculator, and then you should get something like this. V1, so V1 is equal to 16. So basically I got 15.9, but I can just round that off, so to 16 volts. And then for V2, so V2 I got 8.32 volts, and then for V you should get something like 6.2 volts. So we have already solved for V. So what we have to do now is to solve for ix, because we were asked to solve for ix. So now that we have V, how can we find ix? So we have V1, V2, and V. So we can go back to this equation right here. So equation 4. So we can say, we can take that ix to the other side. So now we have V2 minus V is equal to ix. So what is V2? So V2 is 8.32. So we're gonna put that there. 8.32 minus V, which is 6.2. So I have 6.2, and that will be equal to, so 8.32 minus 6.2, that gives us 2.12 amperes. And that's it.